So in 1.1.3, our math notes box talks about domain and range. We've done some work with this before, and you'll really spend some time with it during class tomorrow, working on domain and range by looking at graphs. So we did mention briefly in our discussion of functions this idea that all the inputs give you the domain. It's related to the x values. And when you look at a graph, our x values are how far we move left or right on the graph. So often when we're looking at a graph, when we're looking at how far a function spreads to the left and to the right, those are all key pieces towards domain. If you're looking at a table, you can look at the x coordinates in the table. That can be helpful as well. The range are all of the possible output values, and the outputs are the y values. So you can look at the y value section of a table if that's what you're looking at, or if you're looking at the graph, we know that y values tell us how far up or down the graph we are. So that can often be helpful to notice on a graph how far a graph stretches up or stretches down. Now, most often when we're describing domain and range, rather than just a list of possible values, we want to describe a spread, right? A starting value all the way up through an ending value. So we use this inequality notation like we have here. And sometimes when we want to describe domain or range, sometimes our x values go on forever. It goes on forever in the positive direction. Or maybe it includes a certain number and everything below that. And so you'll notice we use this idea of positive infinity and negative infinity as part of our domain and range to imply or to show that the possible values for x may start at a certain value and then go up. Infinity itself isn't a number. It just describes, it's more of a concept, in terms of numbers going upwards forever. So for example, with range, right? Suppose our range or our graph is anything above 4. It doesn't include 4, or it's anything above 4. You might write it as y is greater than 4. Notice we didn't use the or equals to because it doesn't include 4. Or you could say y is greater than 4, but it's less than infinity, which kind of means it extends on forever. Sometimes you want to describe domain and range by describing what those values can't be. So for example, in this case, if the domain is everything except -3, the easiest way to describe it is x can't be -3. Everything else is fine. And then finally, what if it can be anything? If x can be any number, you could say all real numbers, and here we have it saying as low as -infinity, or as high as positive infinity. It goes forever in either direction. It's also really common to actually just write all real numbers. You could write those 3 words, or there is a symbol for it, which is just a capital R, and you just put kind of a double stem on it. It's an R with the vertical line just shows up twice. So there's some good information on domain and range. We'll continue to build on that.